Amanda Jeffson, and I'm a director of product for avatars and identity at Meta. Today, I'm excited to share our vision for Meta avatars and how we plan to get there with you, our developer, creator, and brand partners. Let's start at the beginning. Why avatars? At its core, Meta has always been a social company. We build technologies that enable people to express themselves and to share with others. And as we move towards the next generation of social experiences, we want to continue to build products that enable new forms of expression and personal connection. We believe that the metaverse can be home to these new social experiences and that avatars will play a central role in enabling these experiences for us. Avatars are your digital representation and will be the way you are embodied in the metaverse and will enable you to feel present with others. We believe most people's first experience with the metaverse will be through their avatars, and that avatars will provide continuity across today's social experiences and tomorrow's more immersive ones. We want to build that bridge to the metaverse for people, developers, brands, and creators. So let's talk about the exciting stuff, our vision for Meta avatars and our near-term roadmap. Our product investments solve for three outcomes. First, empower everyone to create, use, and invest in an avatar that they love. Second, deliver outsized value to developers that integrate our avatars into their experiences. And lastly, unlock new creative and commercial opportunities for creators and brands. These objectives reinforce each other and are critical to a thriving avatar ecosystem that benefits everyone. Let's start with the first objective. Empower everyone to create, use, and invest in that avatar that they love. Today, people can create their Meta avatars by accessing the avatar editor on Facebook, Messenger, or Instagram. We are excited about the number of people who have already created their avatars. To build on this momentum, we are expanding access to creative tools and are simplifying the creation process. To expand access to creative tools in the coming months, Meta avatars will come to WhatsApp. People will be able to create and share their avatar all without leaving the WhatsApp experience. To simplify the creation process, we're building solutions that accelerate avatar creation and offer enhanced personalization. This solution will enable people to generate an avatar simply by taking a video selfie with their phone camera. So instead of starting the process from scratch, people can devote relatively more time to refining an avatar that already captures their likeness. And over the next few months, we will offer even more customization options for people to choose from new hairstyles and textures to more body and face shapes. Once people have created their avatar, we want them to have a lot of great experiences for them to use that avatar with. This effort starts by meeting people where they are. Today, people can use their Meta avatars to express themselves across Facebook, Messenger, and Instagram. They can showcase their avatars in their profile and cover photos. They can share their avatars in stories or use their avatars in messaging. We will continue to build new avatar experiences across all of these platforms. For example, we plan to roll out new ways for people to personalize their avatar expressions, giving people a new way to integrate their own voice, humor, or personality into their avatar. But to truly bridge people from today's experiences to the metaverse, we also need to introduce new embodied experiences across our social platforms. These early embodiment experiences will help people feel stronger affinity to and more represented by their avatars. Our efforts to bring Meta avatars to video calls demonstrate how we can cultivate these feelings across our social platforms. These new features will enable people to present themselves as their avatar when video calling with friends and loved ones. Avatars will mirror their speaker's expressions and movements during the conversation, creating a middle ground between the camera on and camera off experiences. We believe these features will help create feelings of embodiment in our two-dimensional experiences and will habituate people to embodying their avatars on a regular basis. We expect to launch these real-time calling features next year. Regular usage can strengthen people's connections with their avatars. And as people feel more personally connected with their avatars, we anticipate that they will want to invest in even greater customization and personalization. We plan to meet this growing demand via the Meta Avatar Store, a destination where people can discover and acquire new digital outfits and accessories. The Avatar Store launched earlier this year on Facebook, Messenger, and Instagram. Over time, we plan to continually release new items that reflect stylish trends from various fashion, entertainment, sports, and lifestyle brands. These new items can offer people more opportunities for self-expression across channels and platforms where Meta avatars live. We've discussed all of the product investments to empower more people to create, use, and invest in their avatar. Now I'd like to talk about how this will translate into significant value for developers, brands, and creators that partner with us. So let's start with developers. We want Meta avatars to deliver outsized value to developers that integrate our avatars into their experiences. We envision a metaverse co-created alongside our developer partners. To realize this vision, we are building solutions that enable Meta avatars interoperability across certain first and third-party virtual reality experiences. Put simply, we want people who love their avatars and who have invested in them to enjoy them in as many places as possible. That means investing in portability. Today, developers using the Meta Avatars SDK on Unity can bring our avatars and their benefits into their VR applications. But we know that interoperability requires that we service even more developers across more platforms. I'm excited to share that we will soon ship support for iOS and Android in the Unity SDK. With this launch, the Meta Avatars SDK will enable more cross-platform capabilities so that developers can reach and service more people on whichever device that they use. I'm also super proud to announce that the Meta Avatars SDK will soon support the Unreal Engine. We will be testing both rollouts with a small group of developers to start. By enabling portability, we provide immediate value to users and outsized value to developers. Let me break down the key benefits for our developers. The first is our relative scale. Today, billions of people use our products and services. We want to empower all of them to create and invest in their avatars. We want them shopping in the Meta Avatar Store and filling their digital closets with items that enable greater self-expression through their avatars. Developers that integrate the Meta Avatars SDK benefit from the scale and investment in a few ways. They unlock new incremental value for their existing customers who have previously invested in items for their avatars across Meta's platforms. These developers will also offer their prospective customers who have Meta avatars incremental value relative to experiences that don't support their Meta avatars. The second reason is the opportunity for incremental in-app monetization. As mentioned earlier, the Avatar Store is currently available across Facebook, Messenger, and Instagram. But we are bringing the Avatar Store to our developer partners. Next month, we will launch the Avatar Store in virtual reality. The store will be available to people in MetaQuest Home and in third-party applications that have integrated Meta avatars and an entry point to our avatar editor. That means that people can access, explore, and acquire in-store offerings without leaving your in-app experiences. Lastly, we want Meta avatars to empower developers to deliver differentiated in-app experiences. That means making Meta avatars the most expressive, representative, and capable avatar offering in the metaverse. With the impending launch of the MetaQuest Pro, we expect to take a major step towards achieving that goal. The MetaQuest Pro will feature eye tracking and natural facial expressions, which will enable Meta avatars to make eye contact, and relay more nuanced expressions. With these new capabilities, this hardware will enable the best metaverse experience for those using Meta avatars. We will continue to make substantive product investments in the Meta Avatars platform. From these investments, developers can expect even greater diversity and representation and expressivity, balanced with the customization and flexibility that they need to deliver against their in-app visions. What you saw during Mark's keynote is an early preview of our ambitions. For example, next year, developers will get access to our initial implementation of full body avatars and accompanying technologies. That will enable them to implement and customize actions and behaviors that best align with their in-app experiences. In parallel, we are investing in technologies that enable developers to enjoy greater creative freedom when building with and for Meta avatars. We believe that greater creative freedom unlocks new opportunities to build compelling experiences that ultimately drive full funnel outcomes for your applications. To summarize, we want developers to capture as much value as possible when they integrate Meta avatars. We believe that our avatars can deliver on this commercial outcome as a result of relative scale, opportunities for incremental in-app monetization, and enabling differentiated in-app experiences. And that brings us to our final outcome, unlocking new creative and commercial opportunities for creators and brands. So far, I have spoken about how our product investments and Meta avatars directly help people and developers. But these same investments also create new opportunities for creators and brands. On the creative side, Meta avatars will offer new canvases for creation and experimentation. Given Meta avatars' current scale, that means creating for people around the world, all of whom may seek to express themselves differently. Some people love vibrant colors. Others like neutral tones. Some people love exaggerated silhouettes, while others really always reach for the sleek look. While these examples don't even begin to scratch the surface of the breadth of individual preferences and needs, they show how incredibly important it is to co-create alongside our creator and brand partners. And the Meta Avatar Store is how we make that possible. The Avatar Store is a place where we can showcase our latest creations. The store will drive discovery of new creators, brands, and items. It will also unlock a new way for partners to monetize their digital creations. The store will even offer brands and creators operational efficiencies. Partners only need to create and list their items once. Items become available wherever the Avatar Store can be accessed, on Facebook, Instagram, Messenger, and soon third-party VR experiences. Meta avatars can unlock new opportunities for creators and brands, and our efforts to drive scale and portability can directly benefit those who co-create with us. Let me take some time to summarize the key takeaways from today. We are investing in Meta avatars because they are your digital representation and will be the way you are embodied in the metaverse. They will also provide continuity across today's social experiences and tomorrow's more immersive ones. Our product investments have 3 reinforcing outcomes: empower everyone to create, use, and invest in an avatar that they love, deliver outsized value to developers that integrate our avatars, unlock new creative and commercial opportunities for creators and brands that create with us. And most importantly, we are excited to build with all of you. If you want to learn more about either the Meta Avatars SDK or the Meta Avatars Store, we have 2 more sessions for you. You can tune into the Meta Avatars SDK latest developments and learnings for integrating avatars session, where you can learn more about the Meta Avatar SDK capabilities and the improvements that we're making, and hear directly from a few partners who have actually integrated it into their apps. You can also tune into the Avatars Commerce session to learn more about our vision for the Avatar Store, industry trends, and how you can participate. Thank you all for your time, and I personally cannot wait to see what we build together. Thank you.
Hi, I'm Prachi Mohan, and I'm a product manager on the Meta Avatars SDK team. My team's mission is to help you integrate avatars into your apps right out of the box, so that you can bring a deep sense of immersion, embodiment, and presence for your users. Let's take a look at what you can do today, what's coming up in the future, and last but not least, you'll hear from fellow developers about how the SDK opened up new opportunities for them. Last year, we launched the Meta Avatars SDK for Unity on VR, and since then, the developer community integrating avatars has grown substantially. Here are some ways we've seen developers really uplift their experience. Before Golf Plus integrated Meta Avatars, users could see their putter floating around, but not necessarily get a sense of holding them. Adding Meta Avatars made that experience feel more real, because players could see each other and there was just this feeling like you were there with a friend. Forever Bowl built social areas and environments so that their users could hang out together and have meaningful social interactions with each other. We're just beginning to tap into fun, creative, and delightful avatar experiences that give users a real sense of embodiment and presence. And it's going to be really exciting to see what else you all create in the future. So let's talk about some of the key components that make this possible today. Reconciling hand and head positions with a realistic 3D model of a human being is really hard. But we've spent years researching this problem to create highly realistic body poses using our body tracking, simulated eye gaze, and hand gesture technology. This helps users not only feel present in your experience, but gives them whole new ways of interacting with each other. We've heard from you and users that customization is really important. Every human being has a unique way of representing themselves. So we're giving users a diverse set of choices so that they can authentically represent themselves and show up in as many different outfits as they like. And last but not least, we've made multiple enhancements to the SDK that makes avatars load faster, render better, and improves body tracking. Now here's what's coming up. We're expanding Meta Avatar SDK support across platforms and engines. Coming soon, the SDK will support Unreal Engine for VR developers. We're expanding SDK support on Unity for both iOS and Android to help developers build cross-platform experiences. We'll be testing these with a small group of developers before making it broadly available. Next, we'll be launching an overlay editing experience that will let users edit their avatar without having to leave the experience they're in. Many of you told us that this was challenging, but now it'll be much easier to edit your avatar in apps that deep link into our editor. Another key update is that you will get access in the near future to full body avatars and accompanying tech that will enable you to implement and customize actions and behaviors unique to your experience in a low-friction way. Imagine being able to run alongside your friend on the London Bridge, or jump up and down and celebrate a win. It's all going to be possible soon. And finally, the Meta Avatars SDK will support our soon-to-be-released headset, the Meta Quest Pro, where our new APIs will allow you to explore more natural facial expressions to enhance that immersion for your users. So go ahead and check out our Avatars developer page to learn more about our SDK for Unity. We can't wait to see the new ways you'll bring Meta Avatars into your experiences and deepen that sense of engagement for your users. And now, my co-host, Megan Rolfe, will be talking to a few developers about their experience integrating the Meta Avatars SDK.
Thanks, Prachi. Those are some really exciting updates we've got coming down the pipeline. Hi, everyone. Thanks for joining us today. My name is Megan Rolfe, and I'm a researcher here at Meta. Today, we have some great guests joining us who are going to share their experiences with integrating the Meta Avatars SDK in their VR apps. We have Yaz Hatay, who's a senior software engineer at FitXR. He has spent the past 9 years developing, designing, and producing digital content for virtual reality, video games, and experiential installations. Yaz and his team released the Meta Avatars SDK in May of this year to help achieve their mission of making working out accessible and fun for everyone. Then we have Ryan Engel. He's the founder and CEO of Golf Plus. He started this company in October 2017 and began developing for the Quest headset in July 2019. Golf Plus has been using the Meta Avatars SDK since it became available for integration. And last but not least, we have Dariush Zarizadeh, the CTO at Lucky VR. He's a longtime metaverse enthusiast who dove in full-time after falling in love with the Oculus Rift DK1. And Lucky VR is the development partner for PokerStars VR, which was actually a launch partner for the Meta Avatars SDK. And they've been working with our avatar system ever since. Okay, so let's get started. I would first love for each of you to briefly explain, why did your team integrate the Meta Avatars SDK to begin with? What problems was your team trying to solve for? Ryan, do you want to kick us off?
For sure. Thanks for asking. So for us, it was pretty simple. We're a golf application. Golf is a very social activity. And in order to let people play via multiplayer, we really wanted an avatar solution that made you feel like you were on the golf course with other people. So we wanted something that was incredibly expressive, where you could kind of see, smiles, see the eyes moving around, something that wasn't distracting from the natural environment that we have. And the Meta Avatar solution worked out really well for that. It was really easy to integrate, and it was really nice to know that it would continue to improve without engineers on our team having to do the heavy lifting. So we picked it, and it's worked really well for us ever since.
And Dariush?
Yeah, absolutely. So for us, in any social experience, interaction between players is key. And depending on the game, that could be any combination of voice chat, video chat, and other character interactions. With the launch of VR, you have now a fidelity of interaction that's completely unrivaled by any other platform. And it lends itself really well to high fidelity avatar solutions. So a scalable future-facing avatar system is essential to maximize the potential for interaction between players in VR. And that's what really drives our game to a level that, historically you haven't been able to do in online poker, blackjack, whatever, because you've missed those personal interactions that you get between players. And the Meta Avatars SDK is one of the most robust technical solutions available on the market. So it was honestly kind of a no-brainer for us to go with it.
And yes?
In Fitexstar, you can actually participate in multiplayer classes. You can choose a box stance or a high intensity interval training workout, and you can exercise together with up to 6 players. And in addition to the multiplayer, we also have a single player community mode. Other players join you as ghosts that are recordings from their earlier workout sessions. So we have these two modes where we utilize avatars. Before integrating Meta Avatars, our existing avatars were not customizable and lacking expression. And knowing that avatars are fundamental components of social presence that let users represent themselves in an authentic way. So that's one of the reasons why we really wanted to integrate Meta Avatars, because they bring highly expressive and customizable avatars. And this is increasing the VR immersion and enhancing the workout experience.
Amazing. Thanks so much. I especially like hearing about how the SDK can really enhance the social experience in your games for all these different situations and layer onto real life experiences. So great, thanks. We originally built this product to provide developers with high quality avatar solution that can deepen feelings of immersion, embodiment, and social presence for users. But was there any additional benefit to integrating the Meta Avatar SDK that you hadn't quite anticipated? Dariush, do you want to take this one?
Absolutely, yeah. So I've personally always been a big fan of having arms in VR for the player, but I was shocked at how valuable arms were in social games for players other than yourself. When the IK matches up right, and it does a lot of the time with the work that the Avatar team has done, honestly, probably one of the best IK solvers I've ever used. Those arms actually add so much emotion to other players that was lacking in previous iterations when you have just floating hands. So in a social iGaming scenario, the more emotive the avatars, the closer you can get to actual, true poker tells, and the arms help hugely with that, and that's not something I was really expecting.
Awesome. And yes?
Yes. So having we weren't really anticipating having a significant amount of control over the factors that are affecting the performance. Our existing avatars were pretty lightweight, and before integrating meta avatars, we were a bit concerned about a potential performance hit. When started working with the SDK, we saw that there were a variety of options to optimize avatars performance. For instance, there are different shaders that come with the SDK. It's possible to fine-tune the avatars for the best performance and the visual quality by choosing the right shader for your project. And built-in level of detail management, ability to choose between CPU and GPU skinning. These are just a small amount of features that you can tweak with Meta Avatars SDK. So this is the main surprise we had, because it gave us so much power.
Finally, Ryan, what was your experience here?
Yeah, it was really a phenomenal experience. We had not used a different avatar system prior, so we didn't really know what to expect. And prior to the meta avatars, we just kind of had hats and your golf club in your hand. So we were a little bit nervous about the integration, and we weren't sure what to expect. The main thing that we were nervous about was our game only uses one controller. So we really didn't know what was going to happen to your non-dominant hand, and we didn't know how much control we would have over that, or if it would, your hand would get into awkward positions. Thankfully, we were able to kind of get the initial integration done very quickly, and very quickly found that we have, kind of complete control over that hand, and we can even tell the system that the hand is not being used so that it stays in a natural position and kind of has subtle movements that feel very, very accurate. And then when you're going to hit a shot, we're able to take control of that hand and make sure that it's connected to the club so that players don't look like they're swinging with one arm, which was great. An added benefit that we didn't really anticipate is we ended up building a replay system. So after you hit a shot, you can watch a replay of it. And of course, we wanted to see that replay with your avatar. And very quickly, we were able to get the avatar set up so that you could see your swing, you could see the avatar swinging. And it was amazing at how much feedback we got from our players that said just watching themselves swing and seeing their swing from a third person perspective enabled them to kind of identify, swing issues or things that they were working on, or just kind of body movements that were unexpected, and including head position and hand position and things that are pretty technical for a golfer. So that was a huge added benefit that we didn't expect. And the control that we got to kind of put the hand in the right position and for the IK to line up the way that it did was really delightful.
I love hearing that. It's so cool when users end up utilizing new features in that exciting or enthusiastic way. So thanks for that. So Ryan, you actually started tapping into my next question, which is, in what way has the SDK changed the user's experience? Has it unlocked anything that wasn't quite possible before? I would love for Yas to kick us off here.
In our user community, it's quite common to see our users sharing screenshots from FitXR, showing their workout statistics, achievements, or high scores. However, when we released Meta Avatars integration, we started seeing different type of contents coming to our social channels in our community. And these were related to avatars. Users were posting screen captures of avatars where they posed together in our multiplayer lobby. And they also were sharing their gameplay sessions where there were lots of random funny moments that they shared. So I think we can say that this is a reflection of the enhanced sense of embodiment, immersion, and presence that Meta Avatars brought to FitXR.
Awesome. I hope you and your team did the same and created your own avatar screenshots and cool poses as well. Cool. Okay, now, Dariush, how about on your end?
Yeah, so for us, with the sheer amount of just customization available in this SDK, we've seen players really get into like the nitty gritty and really go all out to express their truest self with the avatar system, which is what you want from an avatar system, right? In terms of customizability, it's a huge step up from the older SDK, especially right now. It's improved a ton since launch, and that continues to be the case. The team is working very hard on it. We can tell as the updates come out, and we see the level of interaction and level of what's happening in the face. There's wrinkles now. There's a lot of stuff that's improved since launch. So there's also some really cool stuff in the pipeline that I'm sure I can't talk about yet, but it's super exciting to us. And just the overall improvements we've seen have been incredible.
Wow, that's so awesome to hear. Thanks. So now let's switch gears and talk about the more technical side of things. How is the actual integration process in terms of getting the Avatars SDK working on your app? Dariush, do you want to take this one?
Absolutely. Yeah. So we actually came from the older SDK, and any migration is going to have its difficulties, obviously, but the pain was actually really reduced for this. And I think a lot of that comes down to the work that was done by the Avatar team to make sure that moving from V1 to V2 was as seamless as possible. We worked very closely with them pre-launch to make sure a lot of the pain points we would face were actually resolved before we implemented it. Since then, we've implemented the avatars in some fresh projects where we were testing a couple of upgrades on our end. And that initial implementation without the upgrade was just so easy. It was an absolute breeze, as easy as any SDK implementation can get, honestly. One of the main things that I think surprised us when we were migrating was how customizable the avatars really were. So we had to implement a system to auto-size some apparel, so the watches, the rings that we have, badges, because there is so much customization in these avatars that you can't just have one size fits all. You're going to have to migrate some of your stuff and make a system for that. So that was one of the more surprising things.
So we've heard from some developers that the range of customization and representation is really important to them and their users, as you were just explaining. But for others, it's more about the tracking functionality and the high quality expressiveness. So I would love to know what out-of-the-box features were most beneficial for your app in particular. Ryan, let's hear from the Golf Plus side.
Yeah. For us, it's really hard to compete with the customization that's available. Golf's an interesting activity because what you wear and kind of what you look like is a big part of it. There's no uniform in golf. Everyone gets to kind of wear something that matches their style. So having a third-party system that we could integrate that allows people to customize their look to the way that they want was huge, without us having to create all those options. That being said, tracking for us was kind of equally important and maybe arguably a little bit more important, mostly because we were really worried about, again, what was going to happen with being a one controller game, if we were going to be able to control the other hand and ensure that it lines up correctly. The other concern that we had is in our game, you're obviously doing a golf swing. And when you do that, your hands can go kind of behind your head or above your head, and you might lose tracking of the controller. Thankfully, it doesn't impact performance for us because you regain tracking before you hit the ball. But we were really curious about what was going to happen to the avatar when it loses track of the controller. Is it going to make some crazy assumptions? Are your hands going to get kind of wrapped around your head or end up in some funny positions that would break immersion? And thankfully, what we saw is it's very rare that it does sort of you either can't tell it loses tracking, or it makes great assumptions about where your hands are or should be and where your arms are or should be. So when you see someone swinging in Golf Plus, it looks like a legitimate golf swing. And one of the side benefits that we just never would have anticipated is a lot of, our team can kind of hop in with random people playing online. And after watching them swing one time, we're pretty good at kind of guessing what their handicap is in real life based on their golf swing because it translates over so well. So, for us, the tracking consistency was just beyond what we expected. But again, having the customization is just as important for expressiveness. So it's really hard to pick one over the other.
That's great to hear. I need to get in there and fix my golf swing. Cool. So, Dariush, for PokerStars VR, how about there?
Yeah, so for us, customization is key to any kind of avatar system where players want to represent themselves how they are. But for us, the main feature we're really excited about was getting a high quality, high performance avatar solution into our product without needing to allocate a large internal team to take that on. I think often people will underestimate how complex of a task it is to technically develop an avatar system of this complexity internally. And it's been awesome to have that pressure point just completely offloaded from the team. And technically, they're just getting better and better because they have a whole team assigned to them from Meta, and there's no signs of slowing down with some very exciting features coming in the pipeline. We have, in poker, you have so much is to it's important to have really, really high fidelity interactions, right? Because that's what enables the tells and et cetera. So getting that level of interaction is difficult building your own system. So the ARMs, everything just works so well with the Meta avatars for that. On top of that, the performance, we just launched our Casino 1 level, which has 12 people in it, and we're looking to increase that. And getting a highly performant avatar system that's this malleable, it's just not something we would be able to do internally. So that's been awesome.
Awesome. And Yaz, what about for FitXR?
Actually, the range of customization is definitely one of the most beneficial features. And in addition to that, as Darsh also mentioned before, being able to render the avatar's arms is a game changer because arms are not tracked. So the inverse kinematics system of the avatar is doing an amazing job estimating the arm's position. And as a result, avatars look and feel so natural. And maybe as an addition to this also, I should mention that we used the 32 sample avatars that come with the SDK. We utilized them in our community mode to represent the players who haven't created their meta avatars yet. And I think these are the most beneficial parts out of the box features that we utilize in FitXR.
That's great to hear. Thanks so much. Okay, so that brings us to our final question for today. What tips, tricks, or main learnings would you like to tell the audience, especially if they're considering integrating the Meta Avatar SDK into their app? Let's start with Ryan.
Yeah, this was something that we probably learned the hard way. I would say the biggest change for us is when we started to develop tooling that would allow us to kind of simulate what avatars look like in the editor without having to create builds that run on the Quest. One of the simplest things you can do, obviously, is use Oculus Link or Air Link so that you can, wear your headset while you're running in the editor and see what an avatar is going to do. Without the headset and the controllers, it's very hard to kind of predict what the avatar is going to look like. So I would highly recommend kind of developing some tools so that you can create those simulations. Thankfully, because we had the replay system, it allowed us to basically record all of your head and hand movements to a file. And then we were able to use that file to replay what you were doing and connect that to the avatar system pretty easily. That was huge for us when we were working on the code to determine whether your non-dominant hand should be kind of to your side or should be connected to the club. We were able to kind of create these recordings of a bunch of different scenarios that we thought would be difficult to solve for. And then purely in the editor, without putting the headset on, we were able to run through all of those scenarios and ensure that our solution covered everything. Anytime we ran into a new scenario where something wouldn't connect the way we expected, we could, create a new recording and then solve it in the editor. So that allowed us to have these very robust kind of test cases to ensure that things were working the way that we intended. Lastly, we're a multiplayer experience, so there's always networking. Testing multiplayer is always a lot more time consuming than single player stuff. Rather than having to find multiple people to kind of do that testing and get everyone in certain scenarios, we ended up creating some code that would allow us to take your avatar motion and kind of simulate creating a multiplayer character that was just, shown directly on top of where you were. So you'd be able to simulate someone being in multiplayer. It would still run through the networking pipeline, and you'd kind of see where everything would show up as if it was a multiplayer character. And that allowed us to just make sure that everything was lining up the way we expected, and you kind of get a perspective of what it's going to look like without having to find multiple people to test with. So I would definitely encourage developers to invest in some tooling to create kind of as much simulation within the editor as possible, since there are a bunch of scenarios that you can kind of run into that are difficult to debug in real time.
That's really great to know, and I'm sure a lot of the developers who are listening to this will find that very helpful. So thank you. And yes?
Once actually you have a comprehensive understanding of the capabilities of the SDK, it becomes quite clear how to integrate the avatars in the best way possible to your project. In our case, we also had a couple of points that we needed to implement some workarounds. For instance, while working on this integration, we decided to improve our multiplayer lobby experience by replacing the 2D profile images of our players with their meta avatars. And as a design decision, we wanted to keep avatars anchored to their dedicated slots in the lobby. And in the SDK, we couldn't find the functionality that would allow us to do that. And eventually, we developed a workaround by using Avatar's critical joins feature, which is a feature that already exists in the SDK. So Avatar SDK is a powerful tool. Maybe there are not immediate solutions, but since there are lots of features that you can tweak and change based on your needs. So I definitely recommend experimenting with it before starting the actual integration.
Cool, thanks. And Dariush?
For me, what I'd say is, understand what you're trying to actually accomplish here with an Avatar SDK. If you're a single player game with a specific character, maybe this isn't the right fit. But if you're building an online multiplayer game or a game that just needs a customizable avatar and a system for that, and a robust system for that, and you're not a massive studio with a ton of resources, the Meta Avatars SDK is single-handedly the most powerful, comprehensive solution available on the entire market. And the rapid improvements you get are something that you won't get anywhere else. So if you're looking for something like that, with giving players a level of customizability and a level of fidelity and a level of performance that you need to get performance on the Meta Quest, I would go with the Avatars SDK.
Fantastic, thanks. Okay, so that brings us to the end, and I just want to say how much I enjoyed talking about each of your unique experiences with the Meta Avatar SDK and how your users are using the avatars in really creative ways, like feedback on their golf swing technique or sharing VR avatar memes on social media, even just tapping into the large range of customization and representation options. It's really wonderful to hear. And we've heard all these great tips on how the Meta Avatar SDK can be integrated and enhance the user's overall experience. So I would first like to say thank you to the audience. For those of you who would like to learn more about how the Meta Avatar SDK can enhance your app experience, as well as what resources are available to you, please go and check out our Avatar developer page. Then to our panelists, Ryan, Yaz, Dariush, thank you so much for coming today. It was incredibly insightful, and we look forward to continuing deepening our relationship with you, and of course, seeing what you build next in the metaverse. Thanks.
Wouldn't it be great if you could transport your physical movements into the metaverse? When you look someone in the eye, you could really make eye contact. When you frown, the person with whom you're talking would see your reaction. When you're playing games, you could really dodge those targets that are headed your way. Hello, My name is Kirk Barker, and my preferred pronouns are he and him. I'm a product manager responsible for the Movement SDK, which is part of the Presence platform. The Presence platform is a collection of SDKs and APIs that provide developers with AI, machine perception, graphics, and audio capabilities to build immersive experiences that blend the physical and virtual worlds and help people connect with each other. When paired with MetaQuest devices, Presence Platform empowers developers to innovate and unlock new use cases with mixed reality, social presence, and interactions. Today, we announce the availability of the Movement SDK, which translates your physical movements using face tracking, eye tracking, and body tracking into the metaverse. These improved capabilities enable developers to build enhanced social presence experiences. For instance, in the past, your face tracking could only rely upon audio cues. However, with new sensor technology in the MetaQuest Pro, we can now reflect silent facial movements like smiling, frowning, or even looking surprised. These features bring your character models to life, allowing you to have a nuanced conversation in a VR experience. Using these abstracted signals, developers can animate characters with social presence or provide features beyond character embodiment. One might use face blend shapes to detect if the user's relaxed, eye gaze to determine areas of interest or to improve targeting in a shooting game, or body tracking to animate a character in an action game. We are sure that there are hundreds of use cases that will be supported by our innovative developers. The APIs contained in the Movement SDK will be supported on Quest 2, Quest Pro, and future device with appropriate sensors. We are also publishing these APIs as fully documented OpenXR extensions. Developers can write once and get the best possible results provided by the sensors available on the device on which the app is running. Body tracking is supported across all the Quest family of devices, while face tracking and eye tracking are only supported on Quest Pro. Later in this presentation, we will introduce you to two developer partners, ShapesXR and Arthur Technology. They are planning to use face tracking, eye tracking, and body tracking to bring value to their customers. We will also show you a few internally created examples to demonstrate these capabilities. Now, the first step in translating the physical you into the metaverse is representing your body movements in the best possible quality given the limitation of the sensors provided by the device. To explain how the Movement SDK represents body movement, I would like to introduce my colleague, Vibhor Saxena.
Hi, my name is Vibhor Saxena, and my mission is to help you bring bodies into this embodied internet that we call the metaverse. And today, I am pleased to announce the release of Meta's body tracking. This is the same tracking that drives Meta's own avatars that you see in Horizon or Workrooms, and we've honed it over the years to feel and look really natural. And now, we are releasing the same underlying technology to all our developers. Our focus has been to provide you an easy API that works right out of the box for rich social applications. Body language is a huge part of social experience, and seeing the character body act in a way that a human doesn't totally breaks the immersion of the experience. So, we used a large data set of real human motions to learn and correct the errors that are commonly seen with inverse kinematic or IK-based approaches. All of the clips that you saw above were taken with simple output from a body tracking model and feeding it directly into a character with no complicated tuning or IK constraints. In addition to creating a robust solution with natural movement, we wanted to make it very easy for you to be able to add body tracking to your apps, and so we've added some important capabilities to our API. These are, first, our API works both when the user is using controllers or just their hands, and we provide the full simulated upper body skeleton, including hands, in both these cases. Second, we also automatically take care of cases when user puts down their controllers and start using their hands without any additional logic or handling for the developer. And finally, our API works across MetaQuest Pro, MetaQuest 2, and future MetaQuest VR devices. New improvements to body tracking in the coming years will be available through the same API. So you can be sure that you will continue getting the best body tracking technology from Meta without having to switch to a different interface. We are excited to bring these capabilities to you and working hard to make body tracking much better in the years to come. We can't wait to see how your users move their bodies in this embodied internet. My colleague Nick will now describe natural expression tracking and face tracking capabilities. Thank you.
Hi, my name is Nick Ontiveros. My preferred pronouns are he, him, and I am a product manager at Meta focused on social presence. Today, I'm excited to introduce you to face tracking and eye tracking, two of the many new innovations that will be available through MetaQuest Pro. At Meta, we believe that social presence is a crucial building block of the embodied internet. We want our users in VR to feel like they are having a face-to-face interaction with each other, and the introduction of face tracking and eye tracking is a major part of that vision. Here, let me show you. That's better. As you can see, my character is set up to reflect my real face, eye, and body movements. As you'd expect from the MetaQuest 2, you can see my mouth move while I'm speaking, and I can make eye contact with you, but now I can also do things like smile, look surprised, or even look disgusted. Face and eye tracking doesn't just benefit the audience, it also benefits the speaker. So much in human expression is nonverbal. With face and eye tracking, I can tell when my audience is listening to me because they're making eye contact and looking focused. I can also tell when someone looks like they want to ask a question. Now, let me tell you a little more about how it all works. To give my character the capability to mimic my authentic gestures and expressions, we added a lot of new technology to MetaQuest Pro. Inside the headset, there are 5 IR sensors directed towards the face, 3 sensors pointed towards the eyes and upper face, and 2 pointed towards the lower face. Face tracking is driven by an ML model, which allows the MetaQuest Pro to track a wide range of facial movements. While our users will want their avatars to appear expressive, it's also important that they feel natural, and we hope that developers building embodied characters on top of face tracking will feel the same. For this reason, the signals that we output through the Movement SDK represent fact-space linear blend shapes, a series of 0 to 1 values that correspond with facial movements, like when you scrunch your nose or furrow your eyebrow. These signals make it easy for a developer to preserve the semantic meaning of the user's original movement when mapping signals from the face tracking API to their own character rig, whether that character is human-like or perhaps even something more fantastical. We can't wait to see what creative ways that you will use face tracking and eye tracking to improve social presence in VR. With that, I'll hand it back to Kirk to talk more about social presence.
Since social presence is visible and easy to demonstrate, I'd like to take you through a short demo. With the introduction of the Movement SDK, we're able to support social presence for third-party character embodiment. Working with our artist, we created an alien character that we call Aura. Hey, Aura! Hey, Aura, could you wink for us? Aura, do you remember that joke I told you last week? Hey, so you know, Aura recently had a birthday. Hey, Aura, can you show us how you blew out that birthday cake? As you can see, the facial movements, skin tones, and eye movements are used to make her socially engaging. In addition to the facial movements, the blend shapes can also trigger other actions. For instance, the marking on her hair lights up when she's happy. Now, this is a very important social clue on her planet. Sometimes she will also flare her hair out when she's angry. But you know what? You don't want to be there when that happens. Of course, we can also support high-fidelity AAA game characters. The following is a demonstration of a high-fidelity character using both body tracking and the social presence features. The facial scans for the blend shapes were provided by an external vendor with no proprietary equipment or rigging for capture. As you can see, these are translating Nick into a high-fidelity character who is very believable and natural. Both Aura and the high-fidelity character are provided as samples and are downloadable from GitHub starting this month. You are free to look behind the scenes and see how we implemented the retargeting and rig mapping to get these embodied characters to work. Our documentation also provides guidance and best practices in mapping to different embodied characters. I'd like you to hear from some of our developers. The next presentation is from Inga, who is CEO of ShapesXR. She will describe how they use the Movement SDK.
Virtual reality technology has unlocked entirely new ways to create and collaborate in 3D. At ShapesXR, we've harnessed this opportunity and built a tool that gives creators superpowers. Hi, my name is Inga Petraevska, and I'm CEO of ShapesXR. I'm here today with our product designer, Michael Markman, to show you some of the capabilities of the ShapesXR platform and how we have integrated the Movement SDK. ShapesXR makes 3D design easy and intuitive. In ShapesXR, designers can rapidly prototype their spatial ideas and share them with stakeholders, all in VR, all without any coding skills. Teams can work together in a 3D space and build VR, AR, and mixed reality applications. MetaQuest Pro enhanced social presence makes collaboration more immersive, and teams feel more connected in Shapes.
As product designers, we don't know how real people will interact with the interfaces we make. This is why designers prototype and test their work extensively before development. Previously, the workflow was to create a prototype and then send it out for user testing. Now, the prototype can be created and user tests can be conducted entirely in Shapes. These tests can be observed directly or recorded for later review. By observing our users' behavior, designers can understand if UI elements are discoverable and intuitive. Specifically, these observations allow us to discover friction or choke points in the user flow.
Early user testing allows teams to more quickly iterate and make better informed design decisions for their products. With MetaQuest Pro eye tracking, we can now get much deeper insights into user behavior from these tests. If a user has agreed to provide this information for testing our designs, by following the user's gaze, designers can now understand how users interpreted their interfaces and what exactly grabbed their attention. In this video, the reviewer can see where the user has focused attention by the heat map shown in green. By iterating more in design, teams are able to save tremendous time in development, as well as improve the quality of their final experience.
Finally, I'd like to introduce you to Nick Traber, who is head of product at Arthur Technology, to describe their use of the Movement SDK.
Hi, I'm Nick, head of product at Arthur Technologies. We focus on spatial enterprise collaboration, enabling users to meet, collaborate, and manage their work in a fully digital office that feels like you are physically together. This demands pioneering on two dimensions: presence and productivity. Until now, presence in Arthur had a hard ceiling. We built a system that could recreate faces and outfits reasonably well, but nonverbal communication and expressions never fully translated. MetaQuest Pro and the Movement SDK allowed us to break through that ceiling and offer a much more personal and people-centric experience. With face tracking, we get to see a much more realistic reading of others in a meeting. Are they smiling, showing approval or confusion, or losing attention throughout a session? With body tracking, we get a much more lifelike feeling of presence to another. Gesturing, pointing, and even posture make for a much more realistic interaction with others. For us, this opens the door for many more human-centric use cases. Being able to empathize with training participants who are struggling with a task, seeing a client's reaction to a pitch in a sales meeting, or warming up to a colleague in an icebreaker exercise. This is a significant step forward for us, and it widens the human aspect of our product. The level of realism now enabled through MetaQuest Pro and the Movement SDK helps our users be significantly more effective during workshops and fosters collaboration, ultimately bringing us closer to our mission of allowing humans to work together, independent of their physical location or capabilities. Thank you.
I hope you have enjoyed this presentation and seen the demos and testimonials of these innovative developers. I further hope we've gotten you excited about the possibilities and that now you're thinking of all the cool things that you could do with your app by enabling eye tracking, face tracking, and body tracking. Please take some time to review some of the other sessions and have a great day.
Hi everyone, I'm Randy. I have been working on hand tracking since the initial launch of Hands on Meta Quest 1. At Meta, we see hands as a key source of input, and we envision a future where your hands will move as naturally in the metaverse as they would in real life. In this talk, my colleague Danny and I will discuss new advances in hand tracking and how you can use Interaction SDK to add natural interactions in your experiences to help realize that vision. The improvements that we'll cover today are all available in the Presence Platform. Presence Platform is a collection of SDKs and APIs that provide developers with AI, machine perception, graphics, and audio capabilities to build immersive experiences that blend the physical and virtual world. And it helps people connect with each other too. When paired with the MetaQuest devices, Presence Platform empowers developers to innovate and unlock new use cases with mixed reality, social presence, and even interactions. Let's jump in. I'll kick things off by sharing improvements we've made in hand tracking, and then give you a sneak peek of what's to come. Earlier this year, we introduced an update to hand tracking, version 2.0. 2.0 is a re-architected pipeline which uses new computer vision and machine learning approaches to track hands. It is the first of a step change improvement in tracking quality. It delivers key advances on MetaQuest devices, including improved tracking continuity, robustness to occlusion, hand-over-hand interactions, and more. Let's see some of them in action. We listen, and we know that it can be frustrating when the system loses track of your hands. So we set out to improve tracking continuity with this update. With the upgraded pipeline, hand confidence computations have been redesigned to represent meaningful errors and avoid spurious changes that cause tracking losses. As a result, hand tracking version 2.0 offers greater immersion and more consistent hand experiences in everyday uses. This update also improves partial occlusions. In cases when the camera on the devices do not fully capture your hands, the new deep learning models do a better job at understanding those partial poses. As the video shows, increased robustness allows the tracking of hand-over-hand interactions, like giving high fives, clapping, and even crossing your hands. This opens up the path for more complex gestures involving two hands, such as finger on palm and hand on wrist interactions. If you haven't yet, give hand tracking version 2.0 a try and see the improvements yourself. Speaking of improvements, here's a peek of what's coming in our next update. Hand tracking version 2.1 is the next step in our advancement of our technology. It contains changes across our entire tracking stack, which further improve tracking reliability, provide better extrapolation, and harden our pinch gesture recognition. Let's walk through these changes. We are continuing our focus with improving tracking continuity with Build 2.1. We've tuned our entire stack in an effort to identify instances of poor tracking as quickly as possible. We understand that every millisecond counts, so we've tried to speed up tracker reinitialization and recovery as much as possible. As you can see here, these changes lead to faster recovery from tracking losses and fewer losses overall. With this update, we hope that you can spend less time worrying about the reliability of hands and more time on key components of your applications. Additionally, with Build 2.1, we're introducing a new dedicated neural network to improve the accuracy of our predicted future hand poses. The new network allows the virtual hands to more closely follow the real hand movements under both nominal and faster motions. And this, in turn, means less overshooting and smoother hand poses in your applications. Lastly, in 2.1, we've upgraded our pinch gesture recognition capabilities by switching from pose-driven predictions to direct predictions by our neural networks. This change resulted in a reduction of false detections, even under challenging close-to-pinch conditions, as you can see in this video. We'll continue improving gesture detection and provide you with better and better signals so that you can spend less time guarding against unreliable interactions and improve your applications. That's it for hand tracking version 2.1. This update is coming to MetaQuest 2 and MetaQuest Pro devices by the end of the year. We'll continue improving hand tracking, so stay tuned for future updates. That's it for me. I'll now hand it over to my colleague, Danny.
Thanks, Randy. Hi, I'm Danny, a software engineer on Interaction SDK here at Meta. We've just seen several of the improvements we're bringing to hand tracking, and today I'll be touching on the changes we've also been making for developers incorporating hands and hands interactions into their experiences. Hands are an incredible input, and using your fingers to interact is both compelling and inviting. People have had years of experience interacting with their hands in the physical world. So when it comes to the virtual world, hands interactions must strike the right balance between meeting expectations and adapting to this familiar, yet different, non-physical medium. Last year, we announced Interaction SDK as part of Presence Platform, a library of components for adding hands and controller interactions to your Unity applications. For the first time, Interaction SDK enabled developers to bring interaction models that have been fine-tuned by Meta designers, researchers, and engineers into their experiences. We launched with an initial set of interactions, including ray, poke, grabbing, and pose detection. And just this year, we've also introduced several new features, including gesture detection for enabling custom pose over time recognition to support actions like swipe, distance grab for selecting objects at a distance and pulling things towards you, use grab for enabling secondary actions like pulling a virtual trigger, and touch hand grab for objects that can be grabbed in multiple ways and require dynamic hand poses. We've also released several tools, like debug gizmos, for visualizing interaction states, like hover and select, and debug trees for visualizing recognizer states when building pose and gesture recognizers. And while Interaction SDK places a big emphasis on hands, it also supports controllers and controllers as hands out of the box. Moreover, Interaction SDK is designed to be extensible, cross-platform, and can be used for projects that target both MetaQuest and non-MetaQuest devices. Earlier this year, we also announced First Hand, a hands-first experience that is available to download on AppLab. Built using Interaction SDK, First Hand showcases the power of hands and the magic that you can create with them. In First Hand, you're placed in a virtual workshop where you can interact with switches, levers, and holographic screens. Solve puzzles and build yourself a pair of robotic gloves and then experience their superpowers. I highly recommend giving it a try. With both Interaction SDK and First Hand, the focus of our work revolves around empowering you, developers. We're always listening to your feedback and listening for ways that we can best allow you to make your own magic. Today, I'll be walking through exactly how you can do that and how you can incorporate direct touch interactions, just like the ones you see in First Hand, into your own project. Let's get started. First off, you can download the Interaction SDK as part of the Oculus integration package, either from the Oculus developer website or from the Unity Asset Store. Once you've downloaded the package, import it into your Unity project. The SDK and samples can both be found under the Assets/Oculus folder. If you are targeting a MetaQuest device, we recommend configuring your projects with the recommended settings found on the Oculus developer website. Then, to add Interaction SDK, simply bring the OVR Interaction prefab underneath the OVR camera rig in your scene. Then, for every input you want to support, bring in OVR hands, OVR controllers, or OVR controller hands under that. When you do, make sure to wire up the OVR Interaction prefab to the From OVR data source components for those inputs. You can find several of these examples in the sample scenes. For projects that target other devices, you can use the generic controllers, hands, and controller hands prefabs instead. Simply supply your own data source for your target device. We recommend looking at the From OVR data source components as reference. Once you've configured your input sources, the next step is to add interactions. Interaction SDK provides interactions in pairs of interactor-interactable components. An interactor is a component that acts on, hovers and selects interactables. And conversely, an interactable is a component that gets acted on, can be hovered or selected by interactors. For example, ray interactions are defined by a ray interactor-ray interactable pair, and grab interactions are defined by a grab interactor-grab interactable pair. For objects that support multiple interactions, simply add each interactable type that you want them to support. In first hand, the poke interactor interactable pair enables direct touch with buttons and panels. Let's see how you can do this yourself. The hand poke interactor prefab provides a default setup for hands configured poke interactors. Drag one of these prefabs under each hand and wire up the hand ref component to a hand source, either your left or right hand. If you look at the poke interactor component on this prefab, you'll find that it has a point transform as well as several configuration options. The point transform defines where the origin of the poke interaction is, and by default, it uses the hand index finger's tip provided by a hand joint. Next, add a poke interactable prefab to your scene. This prefab provides a default setup for a direct touch button. If you look at the poke interactable component on this prefab, you'll find that it has a surface, proximity field, and several configuration options as well. The default is set to use a plane surface and a box proximity field to enable direct touch on a flat surface. Once you've added several poke interactable prefabs to your scene, you can now run it and interact with buttons with direct touch. Now there's just one more thing to add. Last year, we introduced touch limiting, a feature you could add to your poke interactions to alter your virtual hand to stay above buttons while you're poking. This is one of several instances in Interaction SDK where visually altering your virtual hand creates a more natural experience. To enable synthetic modifications to your virtual hand, you'll want to use synthetic hands. Add 2 synthetic hand prefabs to your hierarchy and wire up the modified data from source property to each of the left and right hands. The hand poke interactor prefabs you added before, under each of the left and right hands, have a hand poke limiter game object that is disabled by default. Enable it and wire up the corresponding synthetic hand to the hand poke limiter visual. This component listens to changes on the poke interactor and overrides the wrist pose of the synthetic hand during poke. Running the scene now, you should be able to see virtual hands that are touch limited during poking. You will notice, however, that your tracked hands are also still visible. That's because the synthetic hand does not override the original data in the track hand and actually makes a copy of the hand source. This is a useful tool for debugging. If you're not debugging, however, simply disable the hand visual component on each of the non-synthetic hands and run the scene again. And there you have it, poke buttons with touch limiting. Using the poke interactor and interactable pair, you get the heuristics and strategies that we've developed at Meta to make poke feel just right. Some of these strategies ensure that the poke interactor only presses one button at a time, that it can only press buttons from above, that it won't miss buttons on fast motions, and that you can do direct touch on surfaces like cylinders. On top of all that, a Unity canvas integration allows you to route poke interactions to a canvas and enable direct touch on your existing layouts, buttons, and scroll views. Poke interactions are just one of the many options available to you with Interaction SDK, but the idea remains the same for all the others. To add a new interaction to your experience, simply add an interactor-interactable pair, wire up their sources, and you're good to go. You get meta-designed interactions out of the box that you can integrate into your experience for both Meta, Quest, and non-Meta Quest devices. I want to take this moment to also mention some of the new features we have coming your way. Over the next year, we'll be bringing several new samples to Interaction SDK, including hands-based locomotion for allowing you to teleport about a scene using your hands, hand menus for making the most of hand-over-hand tracking and enabling direct touch user interfaces in the palm of your hand. Lastly, MetaQuest Touch Pro controllers enable new controllers as hands capabilities. So you can expect to see samples that make the most of new features, like the thumb rest pressure sensor for squishing and breaking objects, and the index finger sensors to make poke with controllers feel more natural. Thank you for joining us for building natural and compelling hand-based experiences in VR using Presence Platform. With improvements to hand tracking and the updates to Interaction SDK, we can't wait to see what you build.
What if you could deepen user engagement through natural voice-enabled experiences? I'm Rachel Choi, product manager at Meta, and today you'll also meet Aaron Jackson and Julian Odent from our team. Last year at Connect, we announced Voice SDK, part of the Presence platform. Today, I'm happy to share how we're expanding our offerings, improving performance, and making it easier for developers like you to use Voice SDK. By the end of our talk, you'll know how to get started building today. First, let me share the voice-enabled experiences that developers have been building with Voice SDK.
Come here. Jump for me.
Let's play any song. Let's crank it up. Push. Slow. Shield.
Freeze.
What?
Drop your weapon.
If it eases your mind.
Get on the ground.
I'm doing it. Just take it easy.
Mega boom. Tell me a story.
Okay.
Make it this big. Summon butterflies.
Move closer to me. Turn on the radio. Turn on water.
Make some noise.
That last demo is from Whisper, a game we've built now available to you on GitHub. These are just some examples of what you could build with Voice SDK. Now, let's check out the improvements that we've been making. First, text-to-speech is now available, and we're starting off by offering these two voices.
This is one of the voices available in Voice SDK.
And this is another one of the voices you can choose. You can also adjust voices by changing options like the speed.
I can talk fast like a rabbit, or as slow as molasses.
Very funny. I'm a rabbit, but I can talk like a robot. Robot. Robot.
Say again, robot? It's a little hard to hear you in space.
We can't wait to see what you build with our TTS voices.
In V44, we introduced a new dictation module to Voice SDK. Dictation is pure audio transcription, no intense entities or traits. Now, you can get the transcription from longer audio, and there are many ways you can leverage dictation in your game or app. If you need mic support in your in-game keyboard, dictation can really help. What's more, you can build experiences like this sticky notes example for reminders. We're also introducing Voice SDK Toolkit, an open source project aimed at sharing foundational assets, building blocks, and samples for common interactions when creating a custom voice experience. Available now, we're providing new toolkit components to help you onboard a user, help them understand the systems you've created, and handle errors effectively. Creators want to rapidly prototype these voice-driven experiences, so we're releasing design guidelines with the toolkit to help you do just that. You can download the Voice Toolkit today on GitHub, simply add it to Package Manager, or clone the repository's content directly in your assets directory. Keep checking the repository for new assets and tools. We'll continue to add to this resource. Now, for the new launch announcements. We're thrilled to announce the release of Voice SDK for Unreal Engine. And here's a first-hand look at what DigitalLoad has built, leveraging this integration.
Hi, I'm Donnie, Technical Director at DigitalLoad. Voice commands was a promising feature in the first Aspire game. In Aspire 2, we want to take it to the next level. The Voice SDK was a perfect fit for us. We were really impressed by how the Voice AI was able to interpret the player's intent, and so we could easily turn that into the action they want. This is something that we only dreamed about in the first game. In Aspire 2, players have multiple commands where they can hold up and interrogate guards, and also use their voice as a distraction tool. Players got a chance to try out the Aspire 2 demo at Gamescom and PAX, and voice commands were a standout feature. Players really loved being able to talk to the guards.
Freeze.
What?
Over here.
Who said, huh? Someone there? Anyone else hear that?
We're really excited about adding Voice SDK to Unreal Engine. Out of the box, we will be supporting Unreal Engine 4.27 and UE5, with support for immersive voice commands and text-to-speech. We will continue to expand these capabilities. Voice SDK for Unreal Engine consists of two modules, now available in GitHub. These modules include the Voice SDK Unreal module, which is responsible for developer-facing Blueprint nodes and APIs. The second contains the WIT Unreal module, which handles communication with the wit.ai servers within your application. Both are required to use Voice SDK. You can download the release zip from the Voice SDK Unreal repo, which contains the full package, or you can clone them individually. If you download the release package, extract it in your project's plugins directory to install it. Remember, if you clone the repo, the main branch of GitHub is bleeding edge. You'll likely want to check out one of the tagged release commits for your project. Once you've installed the plugin, there are a few things you'll need to do to get voice commands working on your project. First, you'll need to add support for voice to your default engine.ini file in your project's config directory. Add the voice-enabled property you see here at the end of the file. Once you've updated your default engine.ini, go ahead and restart Unreal Engine. You'll see a prompt indicating that Voice SDK and WIT Unreal need to be compiled. When the compilation is complete and Unreal Engine has restarted, you should see Voice SDK and WIT in your list of enabled plugins. A WIT config is a data asset that provides Voice SDK with the tokens needed to access WIT AI, the service that backs Voice SDK. You will need a WIT config file for each WIT application that you connect to. To create one, go to your content browser and add a new data asset with the Add button. Data assets can be found under the Miscellaneous category. When the class chooser pops up, enter WIT in the search box and then select WIT App Configuration Asset as the base class. Once you've created your configuration file, open it up and add your client token. You can learn more about WIT apps in last year's Connect session or in tutorials on developer.oculus.com. Now that you've verified your Voice SDK installation and set your tokens, it's time to set up your app voice experience actor. This actor maintains the connection to an app on wit.ai. Generally, people stick to a single app voice experience in a scene, but there are use cases that might call for more than one. For example, if you have an immersive in-game voice experience and voice-based menu control in the same game, you might want to create a different Wit app for each. By splitting these into 2 Wit apps, your utterances used to train the menu don't overlap with the immersive experience, and it'll further improve the speech recognition accuracy for the context you are actively in. You have 2 options for adding a Wit app. You can drag the base app voice experience actor directly into the scene, or you can create your own actor blueprint that inherits from it and add that instead. I prefer to create a blueprint so I have a dedicated place to handle activations and responses. To do this, first open the content drawer and find the directory you want to put your blueprint in and add a new blueprint class. When the Pick Parent Class dialog pops up, expand all classes and enter App Voice Experience in the search bar. Then choose App Voice Experience as the parent class. It's up to developers like you to decide how you want to initiate voice commands. Voice SDK provides an activate method that can be called when a user is ready. As an example, let's bind the T key to activate voice commands. Open up your App Voice Experience Blueprints event graph. Add a new node and find the T key node. Now, create and activate voice input node by dragging from the pressed pin. There are several ways to react to a response from voice commands. You can react to an intent alone, you can react to an intent and its corresponding entities, or you can decide just how you want to handle the response directly. The most basic way to handle responses from a voice command is to add an event to listen for on-wit response. This event provides a structure with all of the data from your activation, giving you full control over the logic for reacting to that response. This is great if you need full control over your Wit app's understanding payload. Since there's no built-in logic, these blueprints can naturally get complex quickly. If you don't need fine-grained control and are simply reacting to intents, you can use a voice intent matcher component instead. These have a field to specify an intent name, and they will receive an event anytime an activation is completed that includes the specified intent. These work great for simple utterances like fireball, or actions that don't require entities. The voice intent with entities matcher component provides options to match intents as well as the presence of entities. In details pane of the component, you'll find fields for the intent name, as well as an optional and required entities. The intent itself can be made optional, but the matcher will not trigger its event if it is missing any entities provided in the required entity names field. Now that we have voice input set up, let's add TTS to your app to get some audio feedback going. Minimally, text-to-speech requires 2 pieces of data and a TTS speaker actor to function. The required data assets consist of a WIT config and a TTS voice preset config. The WIT config can be the same one you used for voice commands earlier. It simply provides the token needed to make TTS requests. TTS presets are also data assets that you can create through the content drawer, but to simplify things, you can create one in a TTS speaker directly. To demonstrate this, let's add a TTS speaker actor that will function as an in-game announcer. We start by creating a new blueprint. Navigate to the content drawer and add a new blueprint class. Set its parent class to the WIT TTS speaker. The TTS speaker actor has an audio component, caching mechanisms, and a WIT TTS service. These components can be used to customize how your speaker works. As mentioned before, we need to set the data assets for your speaker. Select WIT TTS service and choose a valid WIT config and speaker preset. If you don't have any presets, you can add one here using Fetch Voices and Create Presets buttons. Once you've created a preset, click the preset field and select one from the dropdown. Let's add a custom event to make announcements with one of the built-in DSP effects. First, create a new custom event called Announce. Next, add a format text node and connect the event and formatted text to a speak node. Let's enter some SSML into the text format to allow text input to be spoken with a public announcer effect. To test it out, let's play an announcement that the game is about to begin. Create an announce node and connect it to the begin play event. Set the text parameter to the battle is about to begin. Now all you have to do is drop your blueprint actor into your scene. That's it. Let's try it out.
The battle is about to begin.
You should now have dynamic text-to-speech fully set up in your project. Keeping your users informed about what you're doing with their voice is very important. You should try to be very clear when the mic is active and what text is being seen by wit.ai. To accomplish this, you should include some form of attention system. This attention system can be fully immersive and part of the game or a part of the UI instead, whatever best fits your app. Voice SDK has included the events seen here to provide this feedback to your users. To get you started, we're providing a few basic samples and utilities in the repository. You will find the Shapes demo in one of the sample directories. We also have a couple of useful blueprints set up to get you started with your UI. You will find some basic actors to show microphone feedback, transcriptions, and activation state. If you want to add the samples to an existing scene, simply add one of the widgets in your level blueprint. I need air support in Sector 7.
Roger. Commencing bombing.
You'll notice with the radio example here, we are driving text feedback, activation state, and microphone activity in a fully immersive setup. There are many ways to incorporate this type of feedback into your app, and it's very important to do so, both for clarity and to help facilitate the privacy of your users. Let your attention system fit your game. Your imagination is the limit. Now, I'd like to hand it over to Julian to introduce our next big new feature.
Voice SDK is a great solution for handling simple voice commands. But we want to go beyond simple intents, entities, and traits as provided by wit.ai. Truly natural language interactions involve dialogue state, contextual awareness, and dynamic responses. I'm excited to announce the beta release of Composer for Wit and for Voice SDK in Unity. We're launching Composer to support rich conversations. With the Wit web app, you can now design the way each interaction is handled by your app voice experience. By connecting interactions together as visual components, you describe exactly how you want your experience to respond to each user input. This allows you to take advantage of all relevant contextual information while utilizing intents, entities, and traits like before. There are 4 simple building blocks you can use to create conversation maps in Composer: inputs, responses, decisions, and context. First, inputs. Inputs are any point in the voice interaction that triggers a response to the user, such as an audio wave from the user or a reminder firing off. But in practice, inputs are simply API calls. Second, responses. Responses are effects perceived by the user that result from the input, such as a natural language response issued by an NPC or a sphere growing in size. Responses describe the payload you'll get back from your API calls. Third, decisions. Decisions are branching points in the interactions that lead to different responses under certain conditions, such as the user intent, what objects and characters are in the scene, or even a user preference. And fourth, context. Context takes care of the technical details of a conversation, such as saving an entity for later use, setting a default value for a parameter, or clearing contextual information that's no longer relevant. To manage the dialogue state and the context, you get the context map, your own freeform JSON payload. With this, you can provide anything that is relevant to handling user queries in the scene. You use the context map to store specific information about an extracted entity and to carry the results of client-side operations. Once you're done with composing the graph, You can test it directly from the UI by connecting the power source to the flow, like you would do when building an electronic circuit. You can then send messages and set or update your context map just like you do from Unity with Voice SDK. When testing different scenarios, you can visualize the path taken and debug it at every step. Once you're happy with the results, you deploy the flow so it can be used in your app voice experience. With that in mind, let's build a pizza ordering experience. While iterating on the conversation map, we'll also look at an example VR application that uses the very conversation flows we've built. First, we're looking to support adding items to the order. We start by letting wait know when the user is approaching a waiter NPC so we can greet them. We're then using a custom intent order with custom entities, pizza, size, and pizza type, like pepperoni. The flow starts with an input and then branches using a decision to provide different responses, a couple for actual pizza ordering requests and another to catch everything else. We're using context operations, save, and copy to format the composite entities into arguments for the response.
Hello, and welcome to Pizza Time. What can I get you?
Hello.
I didn't get that. Try, I want a large margarita.
I'd like a small veggie, please.
Got it. A small veggie.
Next, we want to ask the user for the pizza type if it's missing and to set the default size as medium. We're adding another input to gather more information from the user and the context set operation for the default size. Then, we'd like to confirm that the order is complete. We'll use the provided built-in intent with negation to understand objections. If the order isn't complete, we support further additions from the user. Now that we support multiple items, we need to save each one into an array in the context map. We'd also like to give a summary and confirm with the user that the order reflects what they want. To do this, we'll include the order summary parameter in a response. We take advantage of the built-in intent with confirmation before proceeding further. We set a make summary action in the response so we know when to format the order summary and add it to the context map, and then the response can use it. Finally, we process the order and return a confirmation number. It's not enough to say that the order is complete or you got it. We also need to actually send the order to the restaurant. This is what our action process order will take care of.
Hello, and welcome to Pizza Time. What can I get you?
Hi, I'll take a large margarita pizza.
Got it. A large margarita. Anything else?
Yeah, and a regular veggie.
Got it. A medium veggie. Anything else?
Nope, that's it.
I got a large margarita pizza and a medium veggie pizza. Does that sound good?
Yes, it does.
Perfect. Processing your order now.
Thanks.
All set. Your order number is number 23. Thank you.
And there you have it. Using Composer in Unity with Wit.ai, you can now support rich conversations in your app voice experience in a simple way. Give it a try.
We believe Voice SDK and Presence Platform have the power to enable truly immersive experiences. So check out developer.oculus.com for more resources, samples, and documentation. We can't wait to see and hear what you will build.
Hey everyone, you've reached the end of this track, but there is still so much more to come. You might actually have time to watch some of the other sessions that are finishing up, so just head back to the Reality Labs Facebook page or pop into one of the other locations within Meta Squared. Karen, were you able to catch anything?
Yeah, so I checked out the Creator Journey session because I actually already follow all of them on Instagram, and I've used their effects before. These effects, they're some of the most mind-blowing, innovative, creative stuff I've ever seen. And what really stood out to me was when they spoke to how they got started and how they started from really simple concepts and even felt insecure in the beginning. And then seeing how they evolved from that to become as impressive as they are today. I think that's just so encouraging for anyone who wants to get started in all of this.
It's so true. And I'm always awe-inspired by the creativity and the perseverance of this community. It makes the future even more exciting, which is yet another reason why everyone should stay tuned for our final bit of the day. Carmack Unscripted will be live broadcast at 2:30 p.m. Pacific from Meta Horizon Worlds. Now, to those already in the metaverse, head back to the outdoor screen in Meta Square. And while you wait, feel free to continue to explore, network, and chat with other attendees and discover more of Meta Square. Now, to those on desktop or mobile, grab a quick bite, grab a drink, get some coffee, get some tea, but make sure to stick around on the Reality Labs Facebook page as our time with Carmack will start shortly. You do not want to miss his unfiltered take on the future of technology, so we'll see you right back here very soon.